Okay,
Let's-
that was a good time.
Yeah, let's get started.
Great. So good evening, good afternoon, good morning, wherever you are in the world. It's wonderful to have you with us here. This is our first OPAL webinar, so we're super excited and it's really great.
Long time coming. We've been planning this for a while. It's good to finally do it.
It is. So this webinar is about OPAL, the Open Policy Administration Layer, providing real-time authorization. We have with us Asaf Cohen or Vice. I'll introduce them shortly.
Yeah, so.
Hey.
I'm Ort, that's Asaf.
Yeah. Hi, guys.
My name is Noga, and this is Daniel.
Hi.
And before we start, I'm just going to go through Asaf.
Okay. Yeah.
Okay, we're back. Great. They say that if it starts out a bit often, it's going to be an amazing webinar. So
Yeah.
I'm sure it'll be great.
Yeah.
So you will get the webinar recording in your email afterwards. If you have any questions throughout the webinar, then there's a Q&A button at the bottom. Preferably use that, though you can also ask in the chat, but it's just easier for us to track in the Q&A button. And
Yeah, I'm sorry. It's
we'll be sending you a survey. It helps us make better content, so we appreciate if you take just 2 minutes and answer it. So our future webinars are even better than this one. Now I'm happy to introduce our speakers. We have with us, hold on, we have an issue with the sound, I think, again.
No, it looks okay.
Looks fine.
Yeah.
Just got a few messages. Okay. We have with us Or Weiss. Or is the CEO and co-founder of Permit.io and co-maintainer and author of open source OPAL, which is what we will be discussing today. Or is a serial entrepreneur who is passionate about developer tools. Previously, he founded Workout.com, a leading production debugging solution, and he's managing Upwards Israel's largest founders PLG community. Sorry.
No worries.
We're all super excited. And before becoming a founder, Or worked as a lead engineer in multiple cybersecurity and big data companies, the Intelligence Corps, and as a consultant for the Ministry of Defense and as a VP R&D at Netline CP Cyber Division. And I'm also very proud to call him a friend of mine.
That's correct.
And Asaf Cohen, who's the wonderful CTO and co-founder of Permit.io, and also co-maintainer and author of open source OPAL. Asaf loves tech and helping people. I've seen that many times. I can vouch for that. He has built multiple products from the ground up, from cryptography to e-commerce, and he's worked as a software engineer at great companies such as Microsoft, Clarity, and Meta, previously known as Facebook. Prior to that, Asaf served at the IDF Intelligence Corps, and his thesis, this is impressive, his thesis in cryptography is used as one of the privacy foundations in Apple's child safety system. Wow. Great. So
Not too shabby.
yeah,
both of you.
pretty cool.
So with that,
Let's get started. So we're going to go through a quick introduction to authorization, just so we have all the basic concept here aligned together. And then we'll go into talking about OPAL itself. We'll do a demo of OPAL. Asaf will take us through actually how you set it up, how you run it, how you do both updates and policy changes through it. And then we'll go into kind of leading principles and concepts and tips that you can use. And maybe I think the part that I'm kind of looking forward to the most is your questions. We get a lot of questions on Slack, but I think this is another forum where you can go into questions in even greater detail. So we look forward to getting your questions and answering them as part of the webinar. So let's get started. So first of all, we need to kind of set the frame. We're talking about identity access management. Identity access management is comprised of 3 parts. Identity management, that's where you'll find solutions like Azure Active Directory and Okta. Those are on the organization side. That's where you decide who is part of the organization, which identities and entities you have, and you collect different attributes of them. Then we move from the organization side into the application or product side. starting with authentication. Authentication is the bouncer at the door. It checks against your the identity in the identity management, and everyone at the door, it decides if they can enter or not. And it then creates a cryptographically, ideally, it creates a cryptographically signed certificate in the form of a JSON web token, and that propagates the identity and its verification into the application and product itself. In the authentication layer, you can find great solutions like AuthZ, OneLogin, AWS's Cognito, super tokens, Hyper, Magic. There's a really long list of passwordless solutions nowadays. But anyway, that's authentication. Then we move into authorization. So once we decided we let people in, now we need to decide what they're allowed to do once they're inside, or they're inside the building or inside the application. So it's all about who can do what, who do we block, who do we allow to do things, and in which cases. To do that, we guide everything through a policy. Ideally today, policy would be defined as part of the infrastructure as code trend. It would be defined as policy as code. And when we're talking about the OPAL ecosystem, the OPA ecosystem, OPA is a project from the CNCF, which we'll dive into in a sec, and OPAL goes along with it. And for those, we currently write policies in a code language called Rego. We'll dive into that in a few more. But first, let's kind of understand the challenges that we have here. So we're talking about authorization, access control, permissions. This space has changed dramatically in the past couple of years, and it has become extremely hard for three main reasons. One, infrastructure. Moving from monoliths into microservices, instead of having a combined set of things within one service, within that monolith, now we have a bit of access control spread out through our entire application within every little microservice. And if we don't manage it the right way, if we have something kind of just spread out between the services, when we want to upgrade either our application or our authorization layer, we'll end up just having a bad time constantly refactoring those different changes. So there's a need for a slightly different solution to decouple it. And that solution is what we're talking about today with OPA and OPAL. And in addition, it's not just our infrastructure. We're dependent on a lot of third-party services. Nowadays, any application often uses billing from a third-party service like a Stripe or Chargebees or PayPal. And obviously, applications that have physical devices at edge have even more spread out areas where they need to apply infrastructure for authorization. In addition, our requirements and our kind of understanding of what we need as policy from our apps has also become more complex. Every application starts with just let's have an admin and not admin. We, the developers, would be admins, and everyone else is not an admin. Then you kind of move into access lists, but then you quickly find yourself at role-based access control, RBAC, and relationship-based access control, REBAC, or attribute-based access control, ABAC. And these things are constantly moving and changing. So we need a way to dynamically update both our policies and the data that they need. So we need to bring in the data from our different data sources like our billing service that I mentioned, and our Salesforce, and our marketing solution, and our databases, and everywhere else. And the rules that we do in those models also become more complex. Now we want rules like only users from a specific country can log in and use a specific feature. People should be able to use this only during the work week. So policies are becoming more and more complex, and we need a good way to manage them. And finally, security and compliance. The requirements we have from any basic application today often involves having security and compliance in. And there we have things like SOC 2 and ISO, and we have things in privacy around GDPR and CCPA, and likewise. And when you get down to it, when you look at those regulations and compliances, most of them deal in a significant amount in access control. It's really about having processes as part of how you manage your application in access control. So who has access to the data? Who can add more users? Who can change the policy? A lot of the compliance requirements translate into access control. So if we don't have good access control, we're going to have a bad time trying to do security and compliance. So this is like the three key things that make access control hard. And now let's talk about how we can make it easy. So the first step that we need to do is to connect those three layers that we mentioned before as part of the IAM waterfall. So we want to connect to our identity management through our authentication and build our authorization layer to connect to the authentication through standards. The main standard today is JSON Web Tokens, as I mentioned. And then we can build our authorization layer there. And OPA itself already supports working with JSON Web Tokens out of the box. Now we just need to work with the other elements that are brought in. So we probably need to get a full picture of what's going on in the identity management. We need to connect multiple other services, for also information from our billing, as I mentioned before. And that's where OPAL comes in. But the two of those, OPA plus OPAL combined together, can give you a really powerful basis set to build your authorization there. A few words about OPA. So OPA, for those of you who are not fully familiar with it, it's a general purpose policy engine. It's basically a derivative written in Go of Datalog, which by itself is a derivative of Prolog. For those not familiar with it, it runs with a programming language called Rego. And Rego, being a derivative of Datalog, isn't your run-of-the-mill functional programming languages. It's not like Python, it's not like Java, it's not like .NET. It's a logical language. It means that we write multiple rules, and the engine, in this case OPA, runs recursively between those rules to find the answer to the query for us. We use OPA by loading both Rego policies and data into it in the form of JSON documents. In the end of the day, OPA is a glorified memcache, but a really great glorified memcache, where we have that data and policies run in, and it queries everything in memory and gives us answers to those queries. Those queries would mainly be things like, can Asaf access this feature? Can we, in other cases, for example, OPA is obviously matured and grown in the Kubernetes space, and there it's mainly used for admission control, i.e. can we add this container to the pod? But also things like, can this microservice talk to this other microservices? So that's kind of OPA, and we're talking about taking OPA to be real time with OPAL in a minute. And mainly we do that to take it to the application layer. So not just doing classic stuff in Kubernetes, but also taking it to a more highly paced, more event-driven scene in the application layer. So let's move forward. You can find OPA there. Now let's talk about OPAL. So as part of what we did with OPA, we created an application and we started sending queries. So you can see that on the bottom left. So we have our application and it's sending authorization queries into OPA. But now, in order to answer those authorization queries, we need OPA to be up to date with both the policies and data that is needed by the application. But things are changing rapidly, as we mentioned before. So for example, if we want the policy like only users that have paid for a feature can use it, that bit of information exists in something like Stripe. And we want that information to propagate as soon as possible into OPA. So when the user actually comes and uses it in the application, the authorization query would enable them to use it because they paid. Paying users that are denied access are obviously most often frustrated, and we don't want that. And also the other side of it, if we revoke access from a user, if we change the billing configuration, we also want that to take effect as soon as possible. So understanding that we have multiple sources of data, we need to find a way to propagate that data quickly in a real-time fashion into OPA. And that's where OPAL comes in. OPAL comes in with both client and server architecture. Both the client and the server are stateless, meaning you can deploy them and scale them out in Kubernetes, for example, without worrying about how you sync them with their data source. The state in the OPAL deployment is propagated to the edges. It's either the OPA instance itself or the data sinks or data source that you work with. The way it works is that the OPAL clients listen into a WebSocket pub sub channel, a lightweight channel that they create with the OPAL server. Each client then subscribes on that channel to different topics. Those topics are both for data and policy. This enables every OPAL client and its managed OPA instance to get only the data that they need when they need it from the different sources. That way we can apply things like multi-tenancy, separation of different services, and not load too much unneeded data into OPA. So when we want to load data from a different source, we would trigger an event into the OPAL server. We do that either through the OPAL API, through OPAL CLI, or through Kafka. So one of the great things about OPAL is it can latch on automatically to multiple message queue solutions, including Kafka, Postgres Listen Notify, and Redis. So by layering OPAL on top of Kafka, for example, we can just shoot an event into Kafka, and that will trigger a data update. As I said before, you can also do it directly with OPAL's API or with the CLI that essentially uses the API. When that event happens, the OPAL server will send the event to multiple OPAL clients that are listening in according to their topics. When we send the update, we only send the information about the update and not the data that is related to it. The data is collected separately directly by the OPAL client. That enables us to do two main things. One, to get much better performance on the pace of sending updates. So the OPAL client knows that the picture is inconsistent, that the status is changed even before it gets the full data. And then we can use built-in policies to make different decisions according to the inconsistent state. So we can work with the picture as it's updating even before we have the full picture. And the lightweight pub subchannel is really optimized for getting the OPAL clients and their OPA instances to be aware of the change as soon as possible. So that's part one. The other part is it allows us to manage the different planes here separately. We can have the OPAL client deployed into a separate VPC, separate cloud, separate network, and work with the data available there without exposing any of it to the OPAL server. This, by the way, is one of the main requirements that we have for permit IO to enable permit IO to run without it being needing to be exposed to the customer's data at all. So the OPAL client receives, as part of the update, as I started to say before, it receives instructions from the OPAL server on where to fetch the data, and it goes to fetch the data directly from there. The OPAL client does that through a module called DataFetcher. The DataFetcher model is basically extensible. You can create more data fetchers to teach OPAL to bring data from wherever you want. OPAL comes in with a built-in HTTP data fetcher, but you can also use the Postgres data fetcher, and you can use someone contributed an LDAP data fetcher. And in the end of the day, it's just it's a simple Python module with just two functions, fetch and process. So you can extend it really easily. And that's also one of the main reasons why we decided to write the OPAL client in Python. So that's one side of it. The OPAL client can fetch data and bring it into OPA in a very kind of dynamic, seamless fashion without creating too much coupling with the data plane between the other components here. Because it goes and fetches the data directly. And it's optimized to update the picture as soon as possible to minimize inconsistencies. On the other side, so we talked about data, we also need to talk about policy. So OPA knows to fetch data, fetch policies through what's called a bundle server, which it can pull. But A, it can be very slow and cumbersome to manage that. And B, we lack the main processes and concepts that go with infrastructure as code and specifically policies code. The main best practice there is to work with Gitops. So that's why OPAL, in addition to supporting bundle servers as OPAL works with them, OPAL also supports working directly with a Git repository. We can then manage our policies as Rego files in folders within a Git repository and have those folders translated into policy topics within the pub sub. So we basically create a repository, throw in Rego files into it, and automatically throw the name of the file system hierarchy there. The OPAL clients can subscribe to different Rego policies and multiple ones of that. the policies there are just written as Rego, and then we can manage them as code within the Git repository. We can apply tests, checks, benchmarking, and we can obviously tell the OPAL server to work with a specific branch. That way we can basically create CI/CD. We create CI in the process of how we merge the code into a specific branch, and OPAL does the CD for us based on that branch. It will deploy it to the OPAL clients only when we merge that branch, according to, and obviously propagate it to the OPAL clients according to the topics that I mentioned before. So this in a quick rundown is what we call the OPAL architecture. By the way, I didn't say this, or I think we mentioned at the beginning, OPAL stands for Open Policy Administration Layer. That's the initials there. And for those of you coming from the kind of XACML layout, so you can, when you think XACML, you can think about OPA as a PDP, your policy decision point. And you can think about OPAL as both your PAP, policy administration point, and also a management layer for your policy information point. So by combining OPA with OPAL, you can basically be fully compliant with the XACML architecture, or in that fashion, migrate your existing XACML architecture into something more modern like Open Policy. I'm sure there are already questions here, but I think we'll do a demo and then dive into the questions.
Cool. So
Go ahead.
let's do a demo. And sorry, guys, I'm not looking at the camera, but I have to like operate the machinery here. Yeah. Let me just go really quickly.
Oh, you're doing spoilers for the next bit.
Yeah. So yeah. So let's do a quick demo of OPAL. So what we're going to show you is how to run an example config with a single command that essentially pushes a role-based access control policy into OPA's cache. And then we're going to show you how to apply Gitops and push a policy change through Git, and also how to apply a data update through OPAL CLI. So the first thing you want to see is go to OPAL's Git repository on GitHub. And what I'm going to run basically is one of the Docker configs. So we have it under Docker, and you can see we basically have a bunch of Docker examples how to run OPAL. And each one of them you can just download and do a Docker compose up, and it's running, nothing else. But if you want a single command for that, you can just go down, and then we have the TLDR. So that's basically just copy the command. And now let me just minimize the full screen here. Yeah, and let's go and just copy that command, copy paste, and OPAL will be running. So what the config does basically is running both a single OPAL server, a single OPAL client, and the OPAL client is running OPA for us. So everything is up, and we can see that OPAL pushed the example policy through OPA. We can see all the stuff that coming back from OPA's cache, basically, and all the responses that OPA gives. And if you want to take a sneak peek, the policy is under a different repo on permit.io, permit.io OPAL example policy repo. So it's basically a role-based access control policy. So it has a few rules, like if the user is admin, you can do everything. But also just check the user role, and that's basically it. And it has a special flair where it checks that the user is inside the US. We actually check the location of the user, and that's cool for later when we'll push a data update and see that what happens when the IP of the user is changing.
So just to maybe clarify, so you ran OPAL now, and you gave it the Git repository here, this example Git repository to track.
Yeah.
So it automatically downloaded this policy directly from the Git repository into the OPA instance that it's running within that Docker compose.
Yeah.
So we have OPAL server, OPAL client with OPA.
Yeah.
Both the OPAL client and server started. The OPAL server went to Git, so tracked the Git repository there, and then instructed the OPAL client to with that policy, which was loaded directly into OPAL. Sure.
And as you said, OPAL tracks this Git repository, and if I'll like push a new commit, OPAL will track it and will just push the changes to OPA instantaneously. So that's basically Gitops for you. So let's go back to the demo. So we saw that OPAL is running. We can go really quickly to Postman. I'm losing the screen here. Yeah, and if we send our query to OPA's API on port 8181, we can see that the policy is in OPA's cache. We can see that it has all the roles it needs. And also for the users, you can see each user has an IP. So that's basically OPAL is running and OPAL is everything in the cache. So now let's try to do a data update. So how to do that? So OPAL has, I'm sorry, too many screens here. OPAL has a REST API that you can use. And I'm currently at the OPAL servers hosted right now on port 7002. And I'm looking at its Open API config, and I can see that it has a publish data update event endpoint, basically. And we can use that endpoint to push a data update to OPAL. But I'm going to take a shortcut, and I'm going to use OPAL CLI to push that same update that I want to do. So I'm going here in a new shell, and I'm going to basically have a new Python environment and activate that environment and install the OPAL CLI. So let's give it a go here.
So we'll install the CLI. As we said before, you can do it directly through the API. You can do it with the CLI as you're showing here. And you can also do it directly from Kafka or Redis or Postgres Notify. There are multiple ways to trigger updates just to have it work with your kind of infrastructure that you want.
Yeah.
And and within our Git repository, there's under docs, there's an how-to section with instructions on how to do all of those examples that I mentioned. We won't go into them now in the demo, but you can definitely find the documentation, and you can also go into Slack later and ask us specifically on that, or look at questions of people already asking.
Yeah. So I'm going now to ask OPA an authorization query, basically, and I'm going to ask if Bob is allowed to read an object of type finance. So I'm going to ask, and it says true. Basically, Bob has a role, and Bob is located in the US. We can see here in the policy that Bob's location is in the US. So let's go back, run it again. It says, yeah, Bob is allowed. So now I'm going to push a data update through OPAL CLI. I'm going to copy that command. So what I'm doing here is basically pushing a data update that says, hey, OPAL, take this policy source, this data source, I'm sorry, which is an IP API, IP to location API that says, give it that IP's location data, okay, and push it through the policy data channel. We mentioned OPAL works basically with pub subtopics, and put it in OPA's cache under users Bob location.
So maybe just to clarify, so we're using an external service here called country.is. We are not related to it.
Yeah, let's hope it works now, right? Yeah. Let's hope it's up.
Yeah, but it's an external service. It just provides an HTTP API, and we just connect it to fetch data from it with a data fetcher, with the default HTTP data fetcher in this case.
Yeah, I could just as much go to Stripe's API as long as I provide the correct URL and all the headers for authorization that might need, like API key and stuff. So let's run this command. So what we see here is OPAL is processing, and maybe, oh, yeah, it's published successfully. And now we see that OPAL immediately is activated. And we can see that we pushed this data update, and OPAL server pushed it to OPAL client, and OPAL client received the notification of the update, went to bring that data and fetched it and put it under the policy. So now I'm going to go back to Postman, and I'm going to ask the same question again. Is Bob allowed to read finance? And the answer is no, because now if I go and see the data here, I'm going to see that now Bob's location is on another IP. And because we used country IS, we can see that the location is now Sweden. I think it's Sweden, SE. So basically, I think it's Sweden. So the next step would be to push a policy update through OPAL, and let's do it with Git. So I'm currently pulled with the OPAL example policy repo you just saw, and I'm going to open my editor, and I'm going to add a rule that says Bob is allowed to do everything. If the input user is Bob, just allow, right?
Like he's like a super user.
It's like a super user, basically. So I just created this rule, and let's make sure that, sorry, let's make sure again, just to be clear, that Bob is not allowed to do what he wants. So no, Bob is denied, but now I'm going to push that change. So I'm going to do git. So yeah, I'm pushing that change. Let's do
We're
git.
just pushing
add.
the change to Git.
Yeah, so git add the file, git commit, git push. I'm pushing the change. And let's give OPAL some time. Now is a good time to show you that OPAL has two ways to track Git repository. One is through polling. So I can just say a polling interval and OPAL will just poll that change. So now OPAL detected that it has a new commit and pushed the change, and the OPAL client download the new policy and everything is synced. The other way is using a webhook, and we already support GitHub for that. So you can set up GitHub to call an OPAL webhook, and in real time, no need for polling, you can push that policy notification change from GitHub to OPAL, and OPAL will instantaneously update OPAL client and then OPA with the change. So, and we already got to the new polling session, and now we can see that there's no new commits now, but we had it previously. So now that the commit is updated, the policy is changed. And let's go back to Postman and try again. So right now, even though Bob location is not in the US, we can see that the data is not changed. Still SE, Bob is allowed because Bob is allowed to do basically anything.
Whatever he wants.
Yeah.
If it's
so,
Bob, I just whatever you want, Bob, always.
Yeah, so definitely. So that's basically how to push policy update just by using Gitops, and OPAL empowers you to use Gitops to apply policy changes, because you can then use pull requests and testing and any code signals that you want and code reviews to make sure nobody pushes a bad policy change that might affect your
and
data.
Even just doing basic versioning, just tracking what versions of your OPA code you have, and without having to work with those intermediate kind of bundle servers in between, I think is really, it just speeds the process up, makes it easier to work with.
Yeah. So that was a quick demo, and we are available for questions. And let's go back to the slideshow, and let's talk about a new player in the game.
Yeah, so within the OPAL community, we already kind of hinted that we're doing more open source projects around OPAL. And one that we already kind of started to soft launch and will later kind of do a bigger announcement on is OPToggles. I'll give you a quick brief on it, but if you want the full details, just go into the OPToggles repository within under permit.io on GitHub. The idea here is very straightforward. We want our policy not only to be enforced on the back end, we also want it to sync with our front end. Obviously, on the back end, we want to strictly enforce who can do what. But on the front end, we want to adjust the experience. We want, for example, if Bob, well, Bob can do anything, but if in the case that he can, if Bob can't use the billing service, we want him to not even see the button to go to the billing service, because that's a bad experience. Clicking a button and getting an error message, we don't want any user to experience that. We want them to not see that button in the first place. There's already a solution out there to manage how your front end looks, and that's called feature flags. Things like Launch Darkly and Growthbook and Split.io and a bunch of other solutions. They already provide CDNs and SDKs to manage those kind of toggles on the front end. With OPToggles, what you basically do is you sync your open policy in the back end to the front end through feature flags. Every time something changes, OPToggles tracks it through OPAL, and then takes that update, queries OPA, and updates that into the feature flag solution. And then from there, it's just smooth sailing into the feature flag. That way, your backend engineers, or as a backend engineer, you can just continue to focus on running open policy as is in the backend, and you don't need to start exposing the OPA API or a separate API to the front end and wrap that with an SDK. No, you just connect it to the feature flag solution and have your front end engineers work directly with feature flags as they're probably already used to. So that's the concept behind OPToggles. We're doing a launch about that later this month, but you can already access it and start playing with it in our Git repository, and you can find the docs for it at OPToggles as it's written here, .opal.ac. Yeah, so that was that. I think we've covered the basics. Let's have some questions from you folks. That, as I said before, that's the part I'm most excited about.
Yeah.
So I have quite a few questions. It's really interesting. Thank you all for the stuff. It was great.
Thank you,
Really
Saf.
enjoyed
Yeah,
it.
thank you, Or. Thank you, Daniel.
So our first question is from Matisse. He's asking if it's mandatory to trigger a data update by calling the API or by the CLI. Is there any auto update behavior? This is related to OPAL.
So currently, there's no automatic way to trigger updates. You can use either the API or Kafka or the CLI, basically. But it's super easy to set up a webhook trigger. So we are accepting contributions for OPAL. So if you think something is very common, you can put like contribute or give us an idea for a webhook, basically webhook receiver, but it's super easy to write it by yourself. So
yeah, but I think it really depends on what the source of the update is, what is the source of the data. So a lot of solutions today anyhow support webhooks. So for example, if you're working with a CMS system, just as an example, like we, for example, for our website, we use Graph CMS. As part of that solution, you can configure webhooks, and you can just configure that webhook to go directly to your OPAL server. And then it will just work seamlessly. You load more data into your CMS, have the CMS as part of the publish event, trigger a webhook to OPAL. OPAL will go to the CMS solution, fetch the data from there, and it will just work seamlessly.
Yeah.
You just need to find a way, dependent on your data source. And again, the idea is that you can have any data source. Depending on the data source, you need to find a way to trigger a webhook from there. And since a lot of things already support webhooks, in a lot of cases, it will just work out of the box. In some rare cases, you need to maybe add some more adjusting or processing on the webhook itself. But that's something you can do also with the data fetchers, because you can have the basic event go into the OPAL server, triggering it, and then have the data fetcher triggered by it actually do the tailoring and adjusting and maybe working with multiple sources to actually get the right structure of data for OPAL.
Yeah, it really depends on the third-party service. Usually they allow you to modify the schema of the event, right? And then it's just out of the box. And if not, it's just a simple modifier in Python or any other language. It's very, very easy to write.
So
next question.
Now we have a question from Abdallah. He says he has a traditional n-ter architecture, and he's asking how to trigger the data changes from PostgreSQL database.
So with Postgres, I think it would be very classic to work with their listen notify channel. So by the way, that's kind of the default when we deploy OPAL, the default backbone channel. So maybe we should cover that. So we mentioned Kafka and Redis and Postgres listen notify. So when you set up your OPAL server, you can connect multiple OPAL servers through a backbone pub sub. Those that I just listed are the backbone pub sub. And when you do that, you can also have OPAL listen in for events coming from there. So if you have OPAL listening to your past Postgres listen notify, and you're doing changes in your Postgres, you can have your Postgres or something else, your API working on top of it, trigger an event in the listen notify. And that will trigger to the OPAL server, and then trickle down, to the OPAL clients, and it will just work. But just as we touched on it on the question before, you need to find a way to decide where you create that trigger. But in a lot of systems, there's an event-driven mechanism that you can latch onto. So these, and I'm sure for every system you can think of, there's something slightly different. When you work on those systems and you're not sure how to get those events, just reach out to us on Slack. You have the link to that here as well, and we'll be happy to help. Next.
Okay, this came up when you were doing the demo. Joe is asking how, if you could show or maybe explain how you would move a policy between environments. This may be more of a good question, because that's the idea. A policy goes through multiple test environments before being pushed to production.
My immediate, so I'll give a quick answer and maybe you can kind of dive in. So my immediate thought about it is having different branches on your Git repository. And then especially if you're like, when you think environments, you're thinking staging, dev and prod, like production. So you'll have, for example, prod would be synced to the master or main branch. and you have staging as a separate branch and dev as a separate branch. And by merging between them, you'll be moving between those environments. And you can have OPAL in the different environments listening into different branches. Another way to do this is through topics. You can have within the same repository, within the same branch, you can have different folders with policies for different environments. That's what I had. You have it?
There are two ways, basically. There's directories, as Or mentioned, folders in the Git repo, and there's different branches. I think it would be more Gitopsy to do branches. But yeah, whatever floats your boat.
You can actually, a third option is you can actually have multiple repositories and have separate clusters of OPAL servers tracking for the different environments, tracking different repositories, obviously. Yeah.
Obviously.
Yeah. So it's your choice between folders, branches, or repositories. You can do either.
Yeah.
Maybe there are some other options that they don't come to mind.
That sounds pretty comprehensive. Okay, Matisse is asking if there will be more services available in the future for storing policies.
More services to store policies? Oh yeah, for sure. So in general, we built OPAL to be originally to be policy engine agnostic. So we started with OPA just because it's the main leader and we kind of liked it. But there are other engines out there, like also, for example, and yeah, we want to support them too. If you want that, if you want to see more engines and you have specific ones that you want, if it's also or Casbin or something else, please let us know. Write on that in our Slack community. Have other people vote on that. That will definitely encourage us to spend time on it, or maybe also get other people to help us by contributing and working on that. But yeah, it definitely makes sense. And OPAL is architecture for that. There's a separate model called the policy store that basically abstracts the policy engine, and you can have multiple policy stores.
Mm-hmm. I just want to say I'm a big fan both of OPA and also, and we'll want to support them both eventually. And yeah, if you want them sooner, just upvote them.
Okay, Joe is asking about data sharding. Assuming he has 200,000 users and would like to keep some data about some users on some servers, just on some.
Mm-hmm.
So
that's classic for policy topics. You want to
it's data topics.
Yeah.
So yeah, it's basically just topics. You can decide which OPAL clients receive which data just according to the topic list that they subscribe to. It's one of the basic concepts here in OPAL. They're like, we can talk maybe a bit more about more complex sharding. You can also do like random sharding, and you can have chaining as well. That's something that a lot of people are kind of curious about. One of the bigger challenges with OPA is the scale of data. You can't load too much data into OPA because once you get to 1 gigabyte, between 1 gigabyte to 5 gigabytes, depending on the structure of the data, OPA will just croak and stop working.
Yeah.
So the way to solve this is to shard different amounts of data and split them, shard them between different OPA instances through different OPAL clients and different topics. Once you do that, you can also still use the overall data picture from one OPA instance by applying chaining. Chaining would basically be one OPA instance send the query to another OPA instance according to who has the data. It obviously creates a more complex policy. It's obviously more complex to manage, but it's totally feasible, and you can totally do it with OPAL. Yeah. I answered actually more than they asked.
And if your concern is not the size of the data, but you want to make sure each OPAL client sees a different set of data just for privacy and stuff like that, you can use separate topics, but the next version of OPAL will actually allow you to make sure an OPAL client cannot subscribe to a topic is not allowed. We added authorization for authorization, and it's going to be in the next release, so stay tuned.
Yeah, so it's already added to the PubSub WebSocket underlying package, and in the next release of OPAL, you'll have that in. And I think that's a feature that Jake from Tesla asked.
Yeah. So
Jake, if you're here, your feature is ready. We just need to.
Yeah, we just need to do a new release. Yeah.
Okay. So So we have an OPToggles question. This is exciting.
Woo.
Are you saying you toggle the feature per user?
Yes, so OPToggles creates a list of users. So it's not per user, it's per users, plural. So you have
User set.
user set. Yeah, that's like the launch darkly expression.
Yeah.
So you have the user set updated by the policy. So the specific rules that you have for OPToggles would in OPA would create a user list, and that's updated into the feature flag solution.
Yeah, basically you you ask if the user has a feature flag, right? Is if this feature is on, right? So the feature flag solution keeps a list of users, and the OPA rule that is synced into the feature flag solution is simply an OPA rule that returns the list of users that are eligible for that rule. And that's how it works. Very simple. It's a user set.
Will toggle replace launch darkly one day?
No,
No.
because it works with launch darkly.
Yeah, they're friends
So
of us.
The entire idea here was not to have to redo feature flags. They already exist in general. I'm a big fan of not reinventing the wheel. There's already a wheel here. There's no need to reinvent one. We can just use that wheel. There are actually multiple wheels, launch darkly being one of them.
Yeah.
Yeah. So there are a lot of different feature flag solutions that you can work with, not necessarily launch darkly.
Okay, Amit is asking how we can test OPAL. So in OPA, we can write tests with Rego. Is there a different way to test our policies and data structure in OPAL in a specific way, or is it language agnostic?
So first of all, the policies in OPAL are OPA policies. They're completely Rego. Up as long as we talked about maybe having a separate engine, but assuming you're using OPA, it's just Rego code and you test it exactly as before. The only thing OPAL does is propagate those policies into the OPA instances. Again, if you go to the XACML kind of architecture, it's the PAP, policy administration point. It doesn't replace the PDP. The PDP stays OPA itself. So testing the policies themselves remains exactly the same. Nothing has changed.
Yeah.
And it will also work with Styra DAS and other things like that.
Yeah, OPA already has a Rego mechanism, like a test environment for Rego. You can write tests in Rego. And the cool thing is that OPAL enables you to run with Gitops. So you can ask your, let's say, your GitHub actions to run all the OPA tests before you hit merge to master. And then OPAL obviously will only push when you merge to master. So you can have all your tests run before you merge a new policy change.
Regarding testing OPAL itself, so first of all, as a client server architecture, it has unit tests and it has a CLI and it has an API. So you can use all of those to create more tests, both unit tests and integration tests. And if you're already writing those tests, it would be great if you contribute them into OPAL so other people can enjoy them.
We already have a bunch of tests just under tests, I think, in the repository. You are very welcome to contribute more. We are welcoming new contributors to OPAL all the time.
So I have a question from Ken or Sam. I hope I'm pronouncing your name correctly. If not, I apologize. Does OPAL do real-time querying of the data from sources?
Yeah, that's what the OPAL client does with the data fetcher. So upon receiving the trigger event, the OPAL client at that moment would go directly to the data source as it was configured to it from the event coming from the OPAL server, and it would fetch the data. You can obviously create cache layers in addition. You can direct the OPAL client instead of directly to the open source, to the
data source.
Direct open data source. I lost it. I completely lost it. So instead of, we now have bloopers for the vote. So instead of directing the OPAL client directly to the data source, you can direct it to a cache layer that does fetching for you. I've had someone on GitHub in one of the discussions ask that, like, if you want to have the data in the OPAL server, so you don't want the data to be in the WebSocket channel itself, you just want to have another route on the OPAL server, and you can pull the data there and just have the OPAL client fetch it from there. So you can create multiple caching layers and sources to fetch the data from. And by the way, you can also use another instance of OPA as a data source, for example. It's completely generic, so you can go wild here, essentially.
Baptiste, our question mark star, who's asking, what about OPAL using Kafka? Will we have more documentation about that?
Oh, that's a sore spot.
Yeah.
Yeah, we definitely, in general, we definitely need to improve the documentation. We've working on it. There's also currently the documentation, by the way, is just on GitHub. There is going to be a full Dockesaurus based website with better documentations. So that's something that's already planned. And specifically for Kafka, we did write a tutorial. Asaf wrote, I think, a very good tutorial on how to use it. It's
under OPAL docs how to, and there's a Kafka. Sorry.
Run OPAL.
Yeah,
with Kafka.
run OPAL with Kafka. Yeah, and it's a very detailed tutorial, not the best formatting because it's on GitHub, but as Or mentioned, we're working on a doc site for OPAL, so it is coming.
Yeah, by the way, if you, in general, you don't have to wait for a webinar. If you want more documentation of something, you can both ask us on Slack, on open discussion on GitHub, and we'll definitely get to it. It's something that we definitely want to improve on, and we're very excited, not just about creating OPAL, but also getting people to use it. So yeah, it's definitely in the roadmap, but there's already, as Asaf mentioned, there's already a good start for documentation in place.
So we're coming close to the top of the hour, so we'll take two more questions.
Okay.
First of all, why is there a distinction between policy updates and data updates in OPAL?
You want to take it?
That's a good question. Basically, the way it works in modern applications, cloud native applications, is that OPAL was originally architected for Kubernetes. So you have to wait for the next CI/CD cycle to get a policy change, and it's completely fine for infrastructure because you use infra as code. So the policy for that infra, which is also code, you're okay to wait for the next push to affect changes. But in live applications, humans are the ones making the changes, right? I can invite somebody to Google Drive for a document, and I can decide that now he was a reader, now he's an editor, I change his role, or invite somebody new. These human interactions are creating events that are expected to propagate to your policy in real time. So you don't want to wait for the next time a Google engineer pushes Google Drive to production to see if you can access a new document, right? You expect it to happen instantaneously. So basically, these application type updates are small, very small updates that are not part of the policy, but are just like data. So to enable quick data diffs and a good API for that, we decided to basically separate between policy and static data, which never changes or changes on the next CI/CD cycle, to dynamic data, which changes all the time. Okay, and the way OPAL works is it will bring the complete picture every time OPAL is first running, so or after some network disconnection. But basically, OPAL will start and then bring the most up-to-date data into OPAL's cache, and from that point on, it listens on the lightweight pub sub channel on WebSockets. So every time you get a small data diff, you get an update to OPAL in real time. That's the way we architectured it, because OPAL is for live applications. OPAL is for the application layer. That's what it was built for, and that's what works for us. And I think it's a good distinction to do for applications.
Mm-hmm.
Okay. So we talked about OPAL. We didn't talk about Permit.io. So let's finish up with the difference between the two.
Oh, that's a good question. So OPAL is obviously that kind of policy administration point and creates kind of a live channel to update OPA, but that's not where authorization ends. Authorization continues to a lot of experiences on top. You need a back office to manage this entire thing and create the policies and track the audit logs and to create approval flows and stuff like that. So that's the first part. And the second part is customer facing experiences. You want each customer to view their access per tenant. You want them to have user management per tenant. You want them to have audit logs per tenant. And you just want all of that to work out of the box often. You don't want to build all those things over and over again. So that's where Permit.io comes in. Permit.io built on top of OPAL, which is basically the underlying infrastructure, OPAL and OPA, and brings in all the experiences on top. So unless you want to build something in access control, you don't have to. Permit.io is really about enabling developers to focus on building their applications instead of doing permissions and access control. The idea there is that you'll just throw all that crap on us and we'll take care of it for you. But that being said, you always have the option to drop it down into code. Permit.io still exposes OPA to you and OPAL to you, so you can still manage the topics, manage the Git repository, manage the policies themselves as Rego. And we're kind of working that balance between simple use for those that just want to work with it, and you get a policy editor that just creates RBAC policies and ABAC policies for you, and still the ability to write Rego code if you want.
Mm-hmm. Yeah,
that's
something. Yeah, basically OPAL is just like, let's say more DevOpsy tool. It's very powerful. It's very extensible. It has a lot of configuration features, which is, I think, something that is great for open source, right? You want to tweak it as much as you can. Permit.io is just plug and play, right? I just connect it. We have simple wizards for that, and you can just get low code, no code interfaces and just go and run. You don't have to build anything. All the APIs are super simple, and they're meant for basically developers to connect it in a few minutes. That's Permit.io. And OPAL is just super powerful, DevOpsy, real-time delivery system, event-driven layer for your OPA fleet. If you want to build yourself, OPAL is your better bet.
Cool. Okay, if anyone has any more questions, as I mentioned, we have our OPAL community. You're welcome to join us or speak to us on LinkedIn or Twitter. And we also have a calendar here if you want to schedule some personal time with us. We'd love to see you.
Yeah. Thank you guys for coming, folks, for coming. Really appreciate that. And we really look forward to having more of your questions and interactions in our community. Really appreciate it. Thank you guys, and have a great day, night, wherever you are.
Thanks, guys. Bye.
Bye, everyone.